Okay, this is the review of the rational expressions. I'm going to go over the test review problems. All right, so the first problem is pretty simple. This is just to make sure that we understand how reducing fractions works. All we'll do is we'll reduce the x plus 1, because and we'll end up with x times x minus 2 over x plus 1. All right, number 2 is a little bit trickier because there is stuff that we can reduce, but we have to figure out what they are. So the top is a difference of squares, so it will factor as x plus 3 and x minus 3, where the bottom factors as x minus 3 times x minus 3. You could write x minus 3 squared, but this just helps us because then we cancel one of the x minus 3's and we end up with x plus 3 over x minus 3. For number 4, more factoring. So the top is a difference of squares, 2x plus 3 times 2x minus 3. But for the bottom, we're going to have to factor it. And I'm going to do the factoring over to the side here. We're going to use the AC method. And a times c is going to be 2 times 12, or 24. So I need two numbers that multiply together to give me 24 that add up to 11. And those two numbers are 3 and 8. So I'll go 2x squared plus 3x plus 8x plus 12. Group, factor out the greatest common factor. And so the bottom part will factor as x plus 4 times 2x plus 3. So I'll write that in here. X plus 4 times 2x plus 3. The 2x plus 3's cancel, and I wind up with 2x minus 3 over x plus 4. Number 4, everything's being multiplied here, so all I'm going to do is I'm going to cancel the a plus b's, and I'll end up with 7ab over a minus b times the quantity a plus b. All right, number 5 confuses people because they want to expand these two, but we don't want to do that. We just want to cancel. If it was x to the 5th over x to the 3rd, clearly that would be x squared. So we'll see the same thing here where this will cancel and this will become x squared. Also, we can cancel the 3's here, and so we'll end up with x plus y squared over 4. All right, here the 5's cancel. And once again, we can do this two different ways. You can multiply it out and then cancel it, or you can cancel as you go. And you'll wind up with z to the 3rd over 2 times x times y cubed. If that makes you uncomfortable, if that way of doing it makes you uncomfortable, you can always multiply all the way out and cancel later. Now, I really think we should cancel the 5's here regardless. So and then we can cancel 8 over 6, and it's going to be 1/2. 18 over 16 is 1/2. X doesn't have anything to play with. Y to the 3rd divided by y to the 6th is y to the negative 3rd, or y cubed on the bottom. And z to the 6th divided by z to the 3rd is z cubed. And you'll see either we wind up with the same thing that we had when we canceled as we went. All right, here's another one. Everybody can see that that will cancel down to x squared. And so we have x squared times 5x plus 15 over x plus 3. But we need to be careful because there is a greatest common factor in this part of the equation right here. And so that's going to be x squared. I can factor out a 5. And if I factor out the 5, everything on the top is being multiplied, so I can cancel the x plus 3, and I'll end up with just simply 5x squared. All right, this one's a lot. We have to do a lot of factoring. So factor the top part of the numerator of the left fraction would be x minus 3 times x plus 1. And the bottom will factor as x minus 3, x minus 1. I'm going to multiply that over here by x plus 2 times x minus 1. And on the bottom, it's going to factor as x plus 2 times x plus 1. And now we get to canceling. X plus 2's cancel, x minus 3's cancel, x minus 1's cancel, and x plus 1's cancel. Everything cancels, so the answer is just 1. All right, remember our rules of fractions. Dividing by a fraction is the same as multiplying by the reciprocal. Everything here is being multiplied, so m plus 5's cancel, 3's cancel, m's cancel, and so my final answer is 2/3. All right, this one, a lot of people, these complex fractions freak people out, and that's okay, but what we want to do is remember that this really is what it means. The bottom fraction divided by the top fraction. And as we just said, dividing by a fraction is the same as multiplying by the reciprocal. X plus 3's cancel, and I'll end up with 2x over x minus 5. This problem is almost identical to the last one. If it's okay with you, I'll skip the division step and go right to multiplying by the reciprocal. X's cancel. We'll wind up with 3. Or did I make a mistake there? I'm sorry, 3/2. Yikes. So we'll end up with 3/2. I apologize. All right, for this one, once again, I'm going to skip straight to multiplying by the reciprocal. Now, at first glance, it doesn't look like anything will cancel, but I can factor the top because it's a difference of squares. I can factor the numerator over here because it's a difference of squares. And what we will see is we'll see the x minus 4's will cancel and the x plus 2's will cancel, and I'll end up with x plus 4 times x minus 2. And you could FOIL that out, but it's not necessary. You can leave it in factored form. All right, so here now we're adding fractions. Remember, to add fractions, the denominators must be the same, which in this case they are. So all we are going to do is add across the top. So this is going to be x plus 4 plus 2x minus 3 all over x minus 3. And I will get 3x minus 1 over x minus 3. Here we're going to have to reduce this fraction, so the top is going to be x minus 6 times x minus 6. The bottom I can factor out an x. X minus 6 cancels, and we'll be left with x minus 6 over x. And another complex fraction, so x minus 5, and I'm going to go ahead and factor this. This is going to be x plus 4 times x plus 4 times x plus 4 over, and I'm going to go ahead and factor this as well, x minus 5 times x plus 2. Remember, it's multiplying by the reciprocal. So x plus 4 cancels, x minus 5 cancels, and I'll end up with 1 over x plus 4 times x plus 2. Next problem, another division problem, so that means multiply by the reciprocal. So the numerator of the first fraction will factor as b minus 9 times b plus 9 over 2b squared times 2b cubed over, oh, this one's going to be a little trickier to factor, so I'll go ahead and do that in stages. AC is negative 54, so the two numbers that are going to multiply together to give me the negative is going to be, let's see here. Oh, the two numbers are going to be 18 and negative 3. So I'm going to have to do this in stages. It's going to be 2b squared plus 18b. Oh, actually, I like to do my negatives first. It's a good habit to get into. It makes things go a little bit smoother. Negative 3b plus 18b minus 27. And I'm going to have to group this and this. So this is going to be b minus 9. And a lot of times I do these out to the side so I don't have too much writing, but didn't think of it before I wrote on the board, so we'll do it all at once. And this is going to be b times 2b minus 3 plus 9 times 2b minus 3. So I will end up with b minus 9 times b plus 9 over 2b squared times 2b cubed all over b plus 9 times 2b minus 3. And now I can have Cancel-Palooza. It's going to become, the 2's will cancel, the b cubed over b squared will become b plus 9's cancel, and I'll wind up with b times b minus 9 over 2b minus 3. All right, this problem, I'm adding two numbers. They have to have the same denominator. So I'm going to factor the first one, and that's going to be x plus 1 times x plus 1 plus x over x plus 1. So I'm going to multiply the second fraction by x plus 1 over x plus 1. So the two denominators are now the same. And I'll end up with 1 over x plus 1 squared plus x squared plus x over x plus 1 squared. Or x squared plus x plus 1 over x plus 1 squared. And I can't factor the top of that fraction. The numerator of that fraction is prime. So that is the final answer. All right, this one's a little tricky. So first up, in order to do this problem, what I'm going to do is I am going to get the numerator down to a single fraction. So I'm going to do the addition on the top first. So I'm going to multiply this by y over y, and this by x over x. And I'll end up with 3y over xy plus 2x squared over xy, all divided by 3 over xy. which will then give me 2x squared plus 3y over xy times xy over 3. And those will cancel, and I'll end up with 2x squared plus 3y over 3. Number 19, once again, I need to get it so that both denominators have the same number. So I'll factor the denominator of the second fraction, and that'll give me n minus 5 times n minus 4. So this fraction needs n minus 5 multiplied to it, and that'll give me n squared plus 5n plus 5 over n minus 5 n minus 4, or n squared minus 5n plus 5 all over n minus 4 n minus 5. Let's let that sit for just a second so we can see the final answer. All right, once again, we could factor and start doing stuff, but look at this. Two denominators are the same, so all we're going to do is subtract. The common error here is when people write it out, they forget that you're subtracting the entire part of the second fraction. And so you need to distribute the negative. And so you're going to end up with 3r minus r is going to be 2r, but 6 minus negative 2 is going to be 8. And now that we've gotten to this point, we can see if we can factor anything out. Out of the top, I can factor a 2. And out of the bottom, I can factor a 3. And my final answer will be 2/3. Almost done. This one is, once again, this is going to be k minus a over n minus m times n plus n times n minus n, because the numerator of the second fraction will factor because it's a difference of squares. And sometimes it helps just to write this out like this. Remember, k minus a squared is k minus a times k minus a. You can cancel here, cancel here, and we'll end up with n plus m over k minus a. All right, last problem.
Students and staff, thank you for your cooperation. The exercise is concluded. Thank you again.
All right, I need the two denominators to be the same, so my least common denominator is going to be 6xy. Remember, you find that by looking at what is the common denominator of the constants and then containing every variable to the highest power that it appears in either denominator. So in order to turn 2xy into 6xy, I'm going to need to multiply it by 3 over 3. And to turn 6x into 6xy, I'm going to need to multiply it by y over y. And I'll get 15 6xy minus 7y squared over 6xy, or 15 minus 7y squared over 6xy. And I went through those fast just because nobody wants to watch a 30-minute video on math. If you had any trouble with the problems, feel free to rewatch them and come to class with any questions you may have. Thank you.